Okay, so this is the stage two of the implementation next stop recommendation systems, a project under the guide Dr. Maiga Chang, and this is for the MyTAC Global Internship 2021. Stage two of the project involves creating a next stop recommendation synchronizer service. So what this service does is it's trying to make ensure that the app works even if without the internet connectivity. For that, we need to have two things. We need to have the offline map already available, and second thing is we need to have the point of interest database already available. And this also should be have doing it should be done automatically. So without anyone's intervention, the point of interest has to be created for that particular user for that particular region, and it has to be downloaded automatically to the user's phone without anyone's intervention. For that, we have something called cron daemon tasks. So we'll be using cron daemon to actually make two of our PHP scripts automatically execute. One PHP script is for downloading the OSM data, another PHP script is for converting the OSM data into an SQL database. And then finally, we try to make the Android app automatically download all those things to its local database, and that's how the synchronization service works. So let me show you a demo of that. So the first is offline maps. Yeah, so here if you see, I'm using fake GPS to actually set the location. Here I'm setting it to Alberta, Edmonton City, Alberta, where the offline map is already available in the phone itself. And when I open the app, yeah, so when I open the app here, you can see that the offline map is already available, and it says in the toast message that the Edmonton map is already available in the device. And you can also see that the thing works without internet connectivity. The offline map is already loaded in the device. And now if you see the point of interest value count also increase, which means that it's automatically updating. So whenever the Edmonton city is available, the point of interest is automatically imported from its local database, which is already saved in the assets folder. And the map is also automatically imported from the assets folder. So that's how it's working right now. So this is about the offline maps. And the second thing is the synchronization service. So how, like I told you, the synchronization service, the file has to be processed by the server automatically. So here what the demo I'll be showing is I'll be sending an OSM request to the server. The server is going to process it using the cron daemon tasks. So first, it's going to be step by step. So first, the OSM is going to be downloaded, and then there's another script which is run every 5 minutes. So the first script is run every 5 minutes. The second script is run every 5 minutes, but then it's 3 minutes after the OSM script is downloaded. So that's how the cron daemon is scheduled. And so that means that every 10 minutes you will keep getting that updated database in your phone because the cron daemon is always running around the clock. So now I've set it to run in background and I've started the stopwatch here. So now if you see here, there's a file to be processed. That file is the OSM request which is sent by the phone. And if you go in some time, you see that the file to be processed becomes 0 because the OSM is downloaded and it's ready to be converted to an SQL file. So that's the reason why file to be processed became 0. And if you keep seeing it around the clock, so yeah, around the 15th minute, you can see that the point of interest is downloaded. This notification will now, however, not be shown to the user. This is just for the demonstration purpose. We don't want the users to be notified of anything. We want the users to be under the illusion that everything is happening automatically. We don't want the users to know that we are trying to prefetch the point of interest from the internet and so on. That's how it's working. So it's downloading the point of interest. And the other task was for creating a landing page and a dashboard page, which I'll be showing you in a few seconds. So this is a landing page, and if you see that all the images used in this are under the Creative Commons license, and yeah, you could see that we have about the project, about us, where our supervisor is also shown, and then our team are past members of the project, all the publications that are made for this project, and then there's a frequently asked questions. So this is the landing page, and if you see the dashboard is also made using HTML, CSS, and JavaScript. And if you see, you can see a tiles available. All these tiles are actually showing a live count of all the things that are happening. If you see that uh, the administrator can actually see a live progress of what's happening. So he sees the number of users. This is actually implemented using Ajax, where it's getting refreshed at a random time between 5 to 20 seconds. And that's how it's working. It's an Ajax call. And you also see that there are a lot of tabs here. The first tab is actually for the dashboard. If you open the second tab, it's going to show all the files to be processed files, and then there are already processed files. You can also visualize it. You can see the bounding box, where the bounding box for that location data is, and you can also download the location data in your phone, which will be in the data .db format. It's basically an SQL file, correct? And if you visualize it, you can see the bounding box of it. Yeah, it's right here, and that's how it is. So after that, there's a category state time. So there's category state time. Okay, you can also download the process files. The category stay time is actually all the threshold for each category. So let's say that we visit a movie theater. The time to visit a movie theater should be more than the time to visit a hotel or something like that. That's how it is. So the thing about stay time is we still don't know. It can change at any point of time as per the admin's convenience. So we've made a portal where the stay time can change and it can automatically be updated in all the phones around. So that's a portal for changing the category state time. And next is request by city. So request by city is basically not using any API call. So it's going to fetch the location, and there's something called uh, there's no API call. There's a class where you can find out the city for a GPS call, which is completely offline and it's implemented in Android already. So we're using that to find the city. So there's no API call, and which will not be exhausted by so many number of requests a day and all that. It's given by Android, and using that we can actually group all the requests through cities, and admins can actually use this feature to actually see which city has the most number of requests, and if there's no offline availability for that particular city, he can actually upload his own offline map for that particular city. So that's how that works. And then there's frequent patterns. So frequent patterns is all the frequent routes for the GSP algorithm to work. So the admins can actually visualize what are the frequent routes right now and what are they support values. And then there's regular expression. The regular expression for each and every user, the categories expression, the category sequence, a regular expression formed from the category sequence. And then there's finally a bug report. So whenever an uncaught exception is there, the app actually tries to catch that, and it tries to make it into a form where the user can fill in the reason and contact details. So basically you can see, but if the user does not wish to give the reason and the contact details, they can just directly submit it, and the bug stack trace will still be sent to us. And the bug stack trace will actually tell us where the error occurred and what is the device ID, what is the SDK version when the app was used. And basically all this helps us to resolve the bug, and we can fix it in the later versions. And that's how that works. So yeah, that was about the stage 2 of this implementation. Thank you.